Good morning, students. This is our third lecture of solid state, and today the point which we are going to discuss is radius of an atom. The point which we are going to discuss is radius of atom, and we need to find the radius of SCC, that is simple cubic crystal, BCC, that is body center cubic crystal, and FCC, that is face center cubic crystal. So let us begin with SCC. Simple cubic crystal. Now, as you know, how to draw the simple cubic crystal. Eight constituent particle at 8 corner. Eight constituent particles are at 8 corner. And as you know, volume of cube is L cube. But here we are going to use notation A. So this is A cube. So this distance is A, this height is A, and this width is A. Okay. Now this constituent particle I have put with the point, that is actually a center of circle. So here one circle is there, and this is the center of this circle. Okay, I'll draw once more. This is the center of this circle, and this is also center of this circle. So from this point to this point, it is radius. So it is R. From this point to this point, it is R. So can I write A is equal to 2R? Yes, this distance is A, this is the radius, and this is the radius. So A is equal to 2R. So R is equal to A by 2. R is equal to A by 2. So this is the radius formula for SCC. R is equal to A by 2. A is the edge length. A is the edge length. Did you understand this? Yes. Now, the next one which we are going to discuss is FCC, face center cubic crystal. FCC. We'll draw FCC. See here, 8 constituent at 8 corners and 6 at the face. So I am taking this upper face. Actually, at every face there will be constituent particles. But for our solving, I am taking the upper face. So here it is a circle. Here second one. Here third one. So we have got the circles in this way. We are starting from this point till this point. So this is the radius, and this is the center circle. So it is this from this point to this point. It is the diameter. So I can write 2R, and this is the radius. So R. So total 2R plus R plus R. That is, this distance is 4R. Okay. So from here till here, it is A. And from this point to this point, it is A. So starting from this point to reach this point, we are going through this A and plus this A. Means we get in this way. This distance is 4R. This is A and this is A. So can we apply a Pythagoras theorem? Yes, because it's a right angle triangle. So a square plus a square is equal to 4r square. A square plus a square is equal to 4r square. So 2a square is equal to 16r square. 2a square is equal to 16r square. So 2 will go and divide there. So it will be a square is equal to 8r square. So can I write it this way? 8 square is equal to 4. 8 I can write in 4 into 2 r square. So we get, if you remove square, it will be a is equal to 2 root 2 r. A is equal to 2 root 2 r. So r is equal to a upon 2 root 2. R is equal to a upon 2 root 2. R is equal to a upon 2 root 2. Here a is the edge length. Okay. So this is of FCC. Now I will move forward for BCC. Now look here for BCC. Eight constituents are at 8 corners and one in the center. One in the center. Now I am drawing a body diagonal here. So this is a center circle. This is one, and this is one. So here also we are getting 3 circles. This is a body diagonal. From this point till this point, what will be the distance? Again, this distance is r. This is the diameter, means 2r. So this is r. So again we'll get 4r. But from reaching from this point till this point, we'll go through first this distance a, then this distance a, and then this distance a. So same way, in previous example we have applied Pythagoras theorem. Same logic we can apply here. For here it will be now a square plus a square plus a square 3 times. There it was 2 times. A square plus a square plus a square is equal to 4r square. So 3a square is equal to 16r square. So a square is equal to 16 by 3 r square. So a is equal to 4 by root 3 r. So here we get r is equal to root 3 a by 4. So r is equal to root 3 a by 4. Okay. Here we will get 4 upon root 3. So if you remove the value of r, you will get root 3 a by 4. Okay. So all 3 we have finished. All 3 we have finished. Now tell me what will be the radius formula for simple cubic twister. R is equal to a by 2. For face center, R is equal to a upon 2 root 2. And for BCC, which we have seen now, root 3a by 4. Root 3a by 4. Okay. Now I'll do some modifications in this formula so that easily you can remember. If I multiply upside by root 2 and downside also by root 2, this formula will become root 2a upon root 2 into root 2 is 2, 2 2s are 4. So r is equal to root 2a by 4. So how to remember now? FCC, face center. This was the diagram, correct? So we are moving from this distance a, this distance a. So there is 2 times a. So we can remember as root 2a by 4. Root 2a by 4. And in face, in body center, this was the diagram of body center. So this distance is a, this distance is a, this distance is a. So 3 times we are going 1, 2 and 3. So root 3a by 4. Root 3a by 4. So both this formula you need to remember, but I have done some modification so that is easy to remember. Okay, just 2 minutes you go through this, then we'll move for the next point. Okay. So our next point is packing fraction and packing efficiency. First we'll see what is this packing fraction. Okay. Packing fraction, volume occupied by atom, volume occupied by atom upon volume occupied by the atom upon volume of unit cell. Volume occupied by the atom upon volume occupied by unit cell. And if they ask you packing efficiency, same formula you will use. Volume occupied by atom upon volume of unit cell into 100. Means packing efficiency we need to have in percentage, while packing fraction can be in a fraction value. Here we want in percentage. Suppose if a box is given to you and if you are asked to fit a laddus in it, so there will be different ways we will arrange these laddus. Okay, so if in this way if you are arranging it, so this empty space is called as void. This empty space is called as void. And so how efficiently you arrange these laddus, how to calculate it? So first we will calculate the volume of this complete box, that is volume of this unit cell, then volume occupied by these laddus. By that you will get how efficiently you arranged it. Okay, so first we will start for SCC, then you need to solve it for BCC and FCC. Yes, definitely I will help you, but you need to, I will start with SCC. The same logic you need to apply for FCC and BCC. Okay, So the first one. First one is SCC. Okay. Yes. First we need to draw a diagram. Eight constituent particles are at 8 column. So first, volume of cube, it is A cube. Yes, volume of cube is A cube. Then, what is the rank of FCC? Sorry, rank of SCC? Rank of SCC is 1. Already we have seen how to remove the rank. So total 1 circle can be formed out of these 8 circles. So rank is 1. So first we'll remove packing fraction and the answer will multiply by 100. So we'll get packing efficiency. So what was the formula of packing fraction? Volume of unit cell. So volume of unit cell you got A cube upon first volume of what was here? Volume of an atom upon volume of unit cell. So you know only one circle can be formed. So do you know what is volume of sphere? Yes, it is 4 by 3 pi r cube. 4 by 3 pi r cube. So how many circles are there? 1. So here it will be 4 by 3 pi r cube. So we'll solve this. Before that, radius formula for SCC. Now only we have seen r is equal to a by 2. So what will the value of a? A is equal to 2r. So we'll substitute the value here. So we'll get 4 upon 3. Pi's value I'll substitute 3.14 into r cube upon a is equal to 2r. So 2r cube. So it will be 4 into 3.14 into r cube upon 3 into 8r cube. Yes student, just solve it and tell me the answer. If you solve this, you'll get 0.52. If you solve this, you'll get 0.52. And if you want to remove packing efficiency, 0.52 into 100, so it will be how much? 52%. It will be 52%. So how much will be the void? Void means empty space. So 100 minus 52 will be the percentage of void. So percentage of void is 48%. Percentage of void is 48%. That means what? 48% space is still unoccupied and 52% space is occupied. Okay students? Yes. Now next one you will take BCC, body center cubic crystal. So this is the diagram of body center cubic crystal, and you can try the packing fraction and packing efficiency for this. I'll give you 2 minutes, you can try it. Yes, again we'll start with the same thing. Volume of this unit cell or cube we can see, that is a cube. What was the radius formula for this? Do you remember? Okay, BCC, one in the center, body center, correct? So the formula, you know, we are going from this second and third. So radius formula was root 3a by 4. So what will be the value of a? Value of a will be 4r upon root 3. Okay, what is the rank of this? Do you remember the rank of BCC? Rank of BCC was 2. So what is the volume of sphere? Volume of sphere is 4 by 3 pi r cube. 4 by 3 pi r cube. So what is packing fraction? How many circles were there? 2. 4 upon 3 pi r cube into this is a cube. But you know a's value is 4r upon root 3. So the packing fraction will be 2 into 4 upon 3.14 into r cube. 3 into 4r upon 4r upon root 3 cube. So if you solve this, you get packing fraction is equal to 2 into 4 into 3.14 into r cube into 3 into 4 cube is 64 r cube. This will become root 3 into root 3 into root 3. So it will become 3 root 3. Correct? Root 3 into root 3 is 3. And into root 3. So 3 root 3. Yes, students. Solve this and tell me the answer. Yes. Yes, I will tell the answer. Answer will come nearly 0.688 or it can come 0.678. So we'll approximately take it as 0.68. What will be the packing efficiency? 0.68 into 100. How many percent? 68%. Yes. So what will be the percentage of void? Void means empty space. 100 minus 68 means how much percent? 32%. Okay, students. Same logic you need to apply for FCC. Face center cubic crystal. Face center cubic crystal. What will be the diagram? Eight constant particle at eight corner and 6 at 6 face. 3, 4, 5 and 6 at 6 face. Yes. What is the volume of this sphere, or sorry, volume of cube, or what volume of unit cell we can see? That is a cube. What is the radius formula for this? Do you remember? This was the phase diagram. So this distance is a, this distance is a. So root 2a by 4. So what will be the value of a? It will be 4r upon root 2. Yes, what is the rank of this? Rank of this will be 4. If you don't know how to remove the rank, you see the previous video. Rank is 4. What is the volume of sphere? Four by 3 pi r cube. 4 by 3 pi r cube. So how to remove packing fraction? How many circles are there? 4 into 4 upon 3 5 r cube, and this will be into a cube. But a's value you know, so we will substitute this value. 4 into 4, 5 value I will substitute 0.14 r cube into 3 4 yes students. You can solve this. 4 into 4, that will be 16 into 3.14 into r cube. Here 4 cube will be 64 r cube, and here it will be root 2 into root 2 into root 2. That means 2 root 2. Correct? 2 root 2. Here r cube will be cancelled, and you can easily solve this. You will get packing fraction is equal to 0.74. 0.74. Yes, right. So what will be the packing efficiency? Packing efficiency, it is in percentage. So 0.74 into 100, that is 74%. 74%. So what will be the percentage of void? 100 minus 74, that is 26%. Did you understood this? Yes. So again we'll just revise it. Here I'll write SCC, BCC and FCC. What? How much is the packing efficiency? Packing efficiency for this it is 62%, and percentage of void is 42%. For BCC, what is the packing efficiency? Packing efficiency is 68%, and how much is void? 32%. And for phase center, packing efficiency is 74%, and how much is void? 26%. So you see, the most efficient packing is FCC. The question can be asked, which is the most efficient packing among these three? So it is FCC. So because void is quite less in this, 26%. So the most efficient packing is FCC. Yes students, if you have any doubt in this video, you can text me, or you can send a WhatsApp message, or if you are having any problem related to solving this concept, you can tell me. Okay, thank you.